Okay, the notes go in the wrong order. This is 2.4, which actually comes after 2.2 in the note sheet. So this is talking about where derivatives do not exist. So I'm going to take the derivative of a graph where there's a sharp turn. So if I graph this graph of the absolute value of x minus 2 when x is 2, I hope we all know that that's a horizontal shift with a vertex over and a positive 1 slope going up to the right and a negative 1 slope going up to the left. So we're going to do the limit as x approaches this 2 here, and we're going to use our definition from the other stuff. So this is my function at x minus 2, so we're going to have x minus 2 here. That's the function f of x minus the value that we get when we plug 2 in for that x. So this would be 2 minus 2 all over the value of x minus 2. This is one of the definitions we had for a derivative back before on some earlier notes. So when I do this, I hope we all see this whole thing goes to 0. So I have the function x minus the absolute value of x minus 2 over x minus 2 because that whole thing goes to 0. So what I like doing on a graph like this is graphing it. So if you recall, we graphed this same type of graph earlier. And so if I go over to 2, if I plug in numbers, 2 doesn't work at all for either one. But if I plug 3 in, you get positive 1 over positive 1, which stays 1. You plug 4 in, you get positive 2 over positive 2, which gets you positive 1. And if we plug numbers to the left, like negative 1 in here, we get a positive 3 over negative 3, which is negative 1, and so forth. So this graph goes like this. So if I do the limit as x approaches 2 from the left of this function, so that's coming this way, I get negative 1. And if I do the limit as x approaches 2 from the right side of this function, I get positive 1. So what that means is this limit does not exist. So something that we're going to learn here is that the limit or the derivative at a sharp turn does not exist. You cannot find a derivative at a sharp turn. And this whole section is about where derivatives do not exist. The second place they don't exist is here, vertical lines. The definition of a tangent line to a curve does not cover the possibility of vertical tangent lines. For vertical tangent lines, it's possible to use this definition. So the limit as you approach 0 is going to be positive infinity because it's going up, or negative infinity going down. So that makes a vertical line. And vertical lines do not have a slope. So since they do not have a slope and a derivative is a slope, you do not have derivatives where the tangent is vertical. So that's another time you do not have a derivative. So if we try this function down here, we're going to do this same thing down here. We're going to do it just like we did up there above. We're going to take the limit, and it says x equals 0 here. So it's x approaches 0. And then on the top, it's going to be f of x minus f of 0, which is 0. So it's just going to be the f of x part. And then we're going to have minus the c, which is that same 0 right there, all over the x minus c, which is still this same 0 thing here, which is going to equal the limit as x approaches 0. And this is going to end up, when you simplify the power of 1/3 and 1, you subtract exponents and keep them where the biggest one is. This is going to be x to the 2/3 down here. So when you plug 0 in down here, you're going to get, does not exist. You can't fix 1 over 0. Now, if you wanted to graph this thing, it's going to be going to positive infinity. But all I'm really worried about is that f prime of 0 does not exist. It says sketch the graph. I didn't sketch it, so I'm going to sketch it real quick. X to the 1/3, if you plug 0 in, you get 0 out. You plug 1 in, you get 1 out. You plug negative 1 in, you get negative 1 out. And it kind of looks like this. If you want to take a look at it, you can graph it and take a look. So there's your problem. Number 4, example 4. Going on. This is where derivatives fail to exist. So the derivative of function f of x at a point where f of x has a sharp turn, we just learned that, does not exist. And we learned this one where the vertical has a vertical tangent line, does not exist. So this thing over here says sketch a graph of 2 different functions. Sketch a graph of 2 different functions where the derivative of f of x at c fails to exist because of each reason shown to the left. So all you got to do is make a graph over here with a sharp turn, and there would be no derivative here. And over here, you want to make where the tangent line, right in here somewhere, the tangent line has a vertical slope. So that would work for either one of those. It says the theorem below. By the way, there's an infinite amount of drawings you can draw over there that would work. The theorem below, you know what? Did I start this recording again?